We start this problem by drawing ourselves a free body diagram of the pendulum bob. There are two forces acting on the bob. There is the force of gravity mg acting downwards, as depicted by the green arrow, and there is the tension in the cord or the rope T, as depicted by the solid blue arrow. We can resolve the tension into two components, one in the vertical direction and one in the radial direction. In the vertical direction we have t cos theta, in the radial direction it is t sine theta. So if we consider first of all our equation of motion in the vertical direction, the resultant force in the vertical direction must be zero because there is no acceleration in that direction. So t cos theta minus mg must equal 0. So mg equals t cos theta. In the horizontal direction or radial direction, the resultant force is t sine theta. And this is the centripetal force providing the centripetal acceleration. So applying Newton's second law now, we have t sine theta is equal to ma, but the a is the centripetal acceleration, so we can write that as v squared over r, where r is the radius of the circle. If we divide equation 2 by equation 1, we get sine theta over cos theta equals v squared over rmg, which, cancelling the m's, gives us v squared over rg, which equals tan theta. Rearranging that gives us the velocity as the square root of rg tan theta. The period, which is what we're trying to find, can be obtained by dividing 2 pi r, that's the circumference of the circle, by the velocity. So that gives us 2 pi r over the square root of rg tan theta. Just cancelling top and bottom by the square root of r. Now we also know that r is equal to L sine theta if we look at the original diagram there. So therefore the period becomes 2 pi the square root of L sine theta divided by g tan theta, which gives us the final expression for the period, which is 2 pi square root of L cos theta divided by g. Note that the period does not depend on the mass of the bob.